We're going to learn another example of how to factor our given trinomial, this time where our second term is a negative value, which in this case is -5. That's our b that it's being represented by. And our third term, which is 6, is going to be positive, which is represented by the letter c. In order to do this type of problem, again, we can still use our same methods as what we learned yesterday. We want to come up with two numbers that multiply to 6 and add to -5. Remember, our top number is what we have to figure out what two numbers multiply to. Our bottom number is using those same two numbers that multiply to 6. We have to figure out how they add to -5. Let's come up with our list of numbers that all multiply to 6. So we know that's 1 and 6, 2 and 3. And don't forget, we also have to include negatives. So it could be a -1 and a -6. We also have a -2 and a -3. Which one of these add up to our -5? Well, it's not 6 and 1. It's not 2 and 3. It's not -1 and -6. So our last combination must be it. -2 plus -3, perfect. That gives us our -5. This means -2 and -3 are the factors that we're looking for. So we can go ahead and fill them in our railroad crossing sign. Now we want to use these two numbers, -2 and -3, to help us come up with how we can change our given trinomial into two binomials. Now with our two binomials, we know they're going to be held together by multiplication. So I'm going to use my parentheses to help distinguish that I'm multiplying two binomials together. Now we know we can go ahead and fill in our -2 and our -3 values, but we also have to remember that since we're working with x as our variable, we have to make sure that x is included in these two binomials. Now keep in mind, remember, if we had to multiply this out using FOIL or the distributive property, we would multiply the first two x's, and we know x times x gives us x squared, which matches our first term in our given trinomial. We could keep doing this, where we would then next multiply our outer terms, where we get x times 3, and that gives us 3x. We can continue the same way with our inner terms, -2 and x, so that we have -2 times x to get -2x. And then our last terms, -2 and -3, when we multiply those, we end up getting 6. If we took all of these terms and combined them together, we would end up getting x squared plus x plus 6. Well, we know that this result should end up matching our original problem. And it doesn't. So I'm going to go back and look to see where I made my mistake. And I can see it goes back to right down here, where I multiplied x times 3, my outer terms, and I forgot that that was a -3x. So that's going to affect my result when I combine my x's together, which makes more sense now. A -3x and a -2x, that gives me a -5x, which now matches my original problem where I started.